Hello everyone. In the last tutorial we went over decals in general. We solved some of the problems that they may have, such as texture stretching and the decals bleeding through the meshes. This was the result. I also wanted to show you the difference between the material that we created in the last tutorial and the one that comes by default with the when you download them from Fab. We'll be using this decal to create a pathway along our landscape, and we also checked how to create decals. We'll be using this one to create a path along our landscape, and we'll also be using some tire tracks that I found on Fab. Also, we'll be using a combination of PCG splines, PCG splines and decals to create pathways. As you can see, we also gave it a 3D effect. We'll also edit the PCG volume that we created in last episode. Let me just... so that it takes into account the space that the spline occupies and make it so that the grass that spawns close to the spines is actually smaller than the one in the actual forest. I think that's all we're gonna do for today. Let's get started. Let me just clean up the environment and we'll do it later. So you'll need the decals that you want to use. Something I mentioned in the last tutorial but not here yet is that, as you may have noticed, these decals that I'm placing here do not have any color. We're only using the normal map, the opacity mask and the height map to achieve this effect. The way we actually achieve this is that if we go to the master material that we created, you may notice that we don't have any base color, specular, metallic, roughness plugged into the material attributes, since we want to use the ones from the landscape, and this is how we achieve this. Of course, for this one we have a different master material which does implement the base color, the metallic, a specular value and a roughness, since here we are interested in the color. Okay, I think we're set with decals. We can go to our content folder, and then I have a folder here. This is everything that we created in the past tutorials, and this is the main PCG graph for our environment, where we generate all the trees, grass, etc. If you haven't already seen the other videos, it might be a bit hard to follow this one, but I will try to explain everything as good as I can. So what I first created are my blueprint classes of type actor. I created one which I called spline PCG. We simply right click in our content folder, then click on blueprint class and create one of type actor. Name it whatever you want. And then inside this actor, we only did two things basically. On the details panel on the left side, below components, we can add first a spline, this one here, under utility. And we also added a PCG component. If you do not see a PCG component here, it means that you have not enabled the PCG content generation framework plugin. So you'll have to generate this and restart your project. But if you're watching this tutorial, you probably already have done that. And that's all we need to do here. Then I generated childs from this blueprint class. I generated 3 since I will be doing a footpath, a tire track path and the stone path. And then for each of these child blueprints, we're going to need a PCG graph. So to create a PCG graph, we go down here, PCG graph, and name it whatever you want. We're first gonna go over the tire tracks and the footprint, and later on we'll go over the stone path, since I wanted to add a bit more complexity to this one. Let's go first to our tire track. As you can see, it's really simple. First, we're getting the spline data, where we actor filter to self. Then we have a projection node. This is so that the decal automatically projects down to the landscape. It's a really useful node. And we need the landscape data. Each of these you simply get by typing spline and landscape, and then projection is projection. And then after this we have our spline sampler. The spline sampler will allow us to determine when and how often we are spawning this actor. So dimensions is on spline, and then mode is distance. We can also choose by subdivision or number of samples. We'll be using the other... Actually we won't, so I might as well just tell you. Subdivisions will take into account this number. So in each segment, meaning from here to here, there will be 15 decals spawned, since that's what we determine here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or maybe you got it wrong. Let's just check what changing this number does. Yep, as you can see, if we change the number, we change the frequency with which the actor is spawned. But what we're interested is in distance, since we want the end of a decal to be joined to the start of another one. If we reduce this, actually if we increase this number, you'll see that there are segments where the decals don't touch, and it is not a continuous track. So let's put this back to where it was. Depending on your decal, the size of the decal, you'll have to play with these numbers until you get something that you like. And then of course we have a transform points. In this case, because I didn't want the orientation of the decal to change, I have left everything by default, but it's just good practice to have a transform points here. And then we simply get a spawn actor node. The more important option here is the template actor, where we have to choose a decal actor. And then under decal, 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 we choose the one that we want to spawn. Once we have our blueprint actor, and once we have our PCG graph, it's time to go back into our blueprint actor, select the PCG component down here, and on the details panel, if you scroll down, under instance, you will find the graph. We have to assign the graph that we just created to this actor. That way, when we actually get our tire track actor and place it in the world, we can select the spline point, and as you can see, the decals are generated automatically. When you move the actor, the decals will move it with it, but for some reason, if I delete the actor, I then have to select all the decals that were projected and delete them. Now I did the exact same thing for the footprint path. We're going to take a look at it now, which is this one. We have the same thing, get spline data, get landscape data, and we project it onto the landscape. Then the spline sampler. As you can see, the distance between decals is less here, so the footsteps are closer together. And I did want to add a bit of variation. So in our transform points, I do have a bit of rotation, and then I had to decrease the scale so it looked properly compared to a normal sized mannequin. With these types of paths, you can add bends really easily because you're not really going to notice any offset between them. With these type of decals, however, if we try to bend it, you'll start to see how they separate in certain corners, like here. So you have to be careful on how to use your decals, depending on the landscape you're using and on the decal that you want to project. What else did I want to add? Oh yeah, here we also did the same thing. We got our PCG spline path graph and we assigned it to the correct. So in our blueprint actor, we will go to PCG component, and down here we simply add the graph that we want to add. Okay, let's go. Actually, let's do the adapting the PCG environment volume. So let's generate our. Okay. As you can see, we're not generating any grass or debris or trees along the path. The way we achieve this is really similar to the way that we excluded rocks or these types of volumes when we created our PCG environment. We have to open our PCG environment, and where we created our PCG exclusion actors, which, by the way, if you don't know how to do this, we're simply getting the data of the actor of volume that we want to exclude. We're then getting a volume sampler to get this information, creating a reroute node, and then adding difference nodes to exclude the, in this case, tree points from appearing anywhere close to the actors or the volumes that we do here. For the splines, we do the exact same thing. We get our spline data. We actor filter by all world actors, by class, and then we select the ones that we're interested in. And then we choose select multiple. I have the three splines here separated, basically so that I could touch or transform each one independently. But in theory, you could simply, well, in theory, no, I tried it before and it works. But here I get the parent blueprint and get all splines automatically. So instead of having the three independent, you simply would get this one and plug it directly in. But I want to have control over each of these, since if I go to, let's say, the tire tracks and click D on my keyboard to debug this, we'll see that the points generated for these splines will be different from the ones generated here. Since this path is wider, I wanted the points to be wider also. By default, if we, let's take this away. By default, a spline sampler will be, as you can see, really, really thin. So we have to transform the points to increase the width, length, and height of the spline so that the PCG graph excludes it correctly. If I were to plug this in, actually break this, you'll see that now we are generating cross, and if we plug this in here directly, we will not get the result that we want, since we still have grass spawning here. That's the reason we have a transform point with splines, unlike we had with the volume data and the actor data. So let's just plug this back in. Now for the second part of this is how do we get the grass to be smaller the closer they are to the spine, to the spline. So the way we achieve this is that if we go to our section where we have all our grass points generated, and we go close to the end, so just before we are transforming the points, I'll go over this just quickly. We're getting the landscape data, this reroute node, which we're obtaining from here. Surface sampler, then we're doing an attribute filter, meaning that the grass inside this landscape layer will be differently spawned from the grass in these landscape layers. Then we have a difference node for both, where we are excluding actors, volumes, and the spline. Then we have a distance node and a density filter to exclude all the points that are too close to the trees, rocks, saplings, or fern points, which we generated here. In this case we have another distance node, and then we have a spatial noise with the density filter just to give a bit of randomness. Then we have a normal to density. This is to exclude grass from spawning on steep slopes. And here is where we do the scale by density. Here we're using two nodes. The distance, which you should already know. We're getting the distance from our the points that we generate to the spline. And based on that distance, which I put a maximum distance of 150 if you want to do more or less the same, we're getting the execute blueprint node. And inside this execute blueprint, we're searching for the scale by density. And the numbers I selected are 0.8, 1, and 1. So the closer that the grass is to the spline, the smaller it will be. Here, for example, so inside the path layer, which is this one here, you'll notice that the grass is even smaller than on the grass. On the grass layer, I mean. Because in this scale by density, we actually put 0.5 instead of 0.8. So you'll also just have to play around with these numbers until you get what you want. And that's how we achieve for the PCG environment to exclude the splines and also to scale the grass based on the distance from the splines. And we just place this just before the transform points. Now let's go to the rock path. The first thing I want to touch up is the color. So I want it to be a bit darker, so it blends it more naturally with the grass. Okay. I think I can close this. Now here we did the same, but as you will notice, if we go to the PCG environment, for the transform of the other paths, we have numbers of 50, in this case 25, but for this one I had to put 120. so it was wide enough, as you can see. And then let's open the stone path here. This one is a bit more complex. Well, I haven't added this yet because I want to show you what it does later. But basically here we also had to play with the distance increment. And something that I realized in other projects that you will probably see here too, is that when we have slopes in our terrain, the union between the decals changes a bit. So if we go back here, one of the decals is generated here, and we can clearly see when one decal starts and one finishes. Now we could, however, go to our spline rock and change the distance increment to fit perfectly. So right now it's 1267, but I think the correct number was 1279. No, it has to be a bit more. Let me just, actually not this one, this one. That's too much. So as you can see now, it blends pretty good. The problem is, as the slope changes, so do the separations between one decal and the other one. So you'll have to play around with this number until you get something that more or less fits your environment. And another way that we can take the attention away from these separations, I mean, you have to look for the separation which is right here, and if the player is playing and just moving along, he might not even notice. But since we are the developers and we know what the mistakes are, we can try to solve them a bit. And the way I wanted to mitigate this problem a bit is to spawn some of the clothes on top of it, so that you will not be able to notice the seams. So when one decal started and the other one finished. And the way I did this was, if I go back to my spline rocks, from this same spline data, I want to generate a static mesh spawner. And here I have my clovers. So here we simply select PCG mesh selector weighted, and inside our mesh entries we select the mesh that we want to add. I've put a start call distance of 3000 and 5000. So this is when the mesh will start to disappear based on the distance from the player to it. I ticked off evaluate world position since I don't want the clovers to have any wind. And the shadow cache invalidation behavior is static. These are all the options that we went through in our foliage optimization tutorial. It's not really necessary if you just want to try this out, but just to take into account. So here I have my clover 03, 02 here, and 01. The reason why I have them separated and not the 3 here is because I wanted them to all have different transforms. Now, I want the clover to spawn where the seams are. So, as you will notice, I have 2 spline samplers. I also have the mode is distance, and the distance increment is exactly half of this number. And this one is exactly half of this number. So that they will always and a bit more often spawn around the seams. So if we plug these back, you'll see that we are spawning our cloves. Now the reason this happens, and this is a problem that you might come across is that materials by default will take the decals that are projected onto them. And since the volume of this decal occupies the space where the cloves are, the decal is projected. The way we solve this is if we go to our clove material, we can go into our details panel, type decal, and we can change the decal response. So right now it's getting the color, normal, and roughness of the decal. For cloves, I'm not interested in whether or not they receive decals, so I'm going to select not. And then I click apply, and we've solved that problem. However, this means that these cloves will not receive any other decals. For example, let's say we kill an enemy and the enemy falls on the floor and generates a puddle of blood. The blood will not be projected into the onto the cloves with this method. There are other methods of decal exclusion that you might find more appropriate for your project. But since we're focusing today on PCG and how to create paths, we'll not go over that today. But this is just a quick solution if you want a certain material not to receive any decals at all. But just so you take into account that this may happen, let's move the blood back. And as you can see, since we put the distance half of the decal distance increment and here a quarter, you'll see that the cloves are randomly generating. For example, here, I believe it was, here's the seam, but because the cloves are here, it covers it a bit. So this is just an idea that you can use to maybe mitigate some of the problems and defects that your level may have. Each of these cloves has a different transform. Since I wanted the cloves to be positioned covering the whole seam, so I played around with the numbers and I found that putting the transforms that comes from these spline samplers from this one is the bigger mesh, so this is the one so here I displaced it -90 to -150 and here 90 to 150. So even though the cloves would be generated in the center, they are displaced to the right and to the left, covering the width of the decal. Again, these are numbers that you will have to play with depending on the meshes that you're using or the decal that you're using. But as you can see, you can achieve good looking things with this method. I also wanted to mention that I found a really good channel where he covers a lot of PCG stuff, in particular using splines, which I found really helpful for my main projects. So I'll link the channel in the description of the video. And that was all for today. I hope you enjoyed the video, that you learned something, and if you did, please don't forget to like and subscribe. I'll see you in the next one.